Hello friends, welcome to our channel instrumentools.com. In the series of real life PLC and HMI examples, today we are going to see PLC stone cutting machine. So this is, you can see, a smart stone cutting machine which cuts through very precisely. It works fully automatically and it can work on slate, granite and marble slabs. So this machine consists of IoT enabled HMI. So we can work on Internet of Things through this HMI also. Besides that, it has LXV 5 series Wecon PLC and servo drives and servo motors for 5 axis control. So you can see here there are 5 axes and 5 servo drives and motors, and which can help us to make different slate, granite and marble slabs. This is the interactive HMI screen for each shape, and because of Internet of Things, we can operate this from remote location also. And this is how the real panel looks like. You can see these are the servo drives, and you can see it can make any shapes with very precision. It has wide portfolio of products, and you can see this is the A-axis motion. It can cut in curvature also, and it also has the visual positioning sensor. You can see the current position of the grinder. This is the overview of the complete machine. So you can see it can cut in slanted position and complex work also. So let us understand the working of this machine and also its construction. So let's start. Here you can see this is one standard plate or a standard shape. So manual cutting of this is possible. But when you want shapes like this, manual cutting is little difficult and we can't do same shape if we want to do mass production. That's why it's better to use this smart stone cutting machine. Manually cutting these shapes with so much accuracy is time consuming and also require high skilled manpower. This is the reason we need this smart stone cutting machine which has HMI, PLCs and servos, and you can see this is the complete machinery. But how does it work? This is only the reason why we are making this video. So let's see. This is the complete overview of the machine, and I'll show you from this slide only. You will be able to understand the most of the things about the machine. So first of all, in the any CNC machine, there are three main axes which are called X, Y and Z. So here you can see this cylinder. Here there is the movement for Z axis which moves this cutting wheel or cutting motor grinder in up down position. So here you can see up and down Z axis. Now this is the whole tray. In this tray, this assembly can move towards right or towards the left. So this axis is denoted as X axis. So it has its own motor, and here you can see this is the flexible cable arrangement, because this motor, here there will be Z axis motor and X axis motor will be touching to this platform. So if the motor rotates, it will move this assembly in right or left direction, and this is the flexible cable, because this assembly has to move anywhere. So the cable also moves along with this. Here also you can see if this assembly moves backwards, okay, so that is the y axis direction. It can move backwards or come forward. So this is the cables for y axis. Now this is the common in every machine, but what is the new in this machine? That are the a axis and the c axis. So here there is one main motor which only rotates the grinding wheel, or we can say cutting wheel, but A-axis can rotate this complete assembly in 360-degree. There is the C-axis only. So in previously we have seen that this right now this plate is vertical completely 90-degree to this board, but due to C-axis we can make this wheel slanting. So we can cut slanting angles also. And this wooden bench, you can see this is our workbench where we place our marble or granite which we want to process, and through this panel, control panel, we can operate this machine. So all these axes consist of servo motor which is controlled through PLC, and that PLC is controlled through HMI screen. So this is the complete overview of the machine. Operation of each axis in this machine. How all the axes actually work. Here you can see this is one sensor and there is one X mark over here. So we have to focus on this portion to observe the movement of A axis, how the A axis actually works. And this assembly is moving left of this slide. Okay. So that is the X axis operation. So in this way, we will see operation of each axis one by one. So let me play this video. Observe that this X will move toward this proximity sensor. The distance between X and this sensor is reducing. Okay. So this is how it rotates. You observe this plate. Here you can see the shape. It is moving in X direction and it rotated the plate like this. So the curvature is formed over here. So this curvature, you can see this rotation. So this rotation is due to A axis. Now it will go little upwards. So that will be Z axis. You see it going upwards. Now again it will come back. It will come down and then it will come back. Now again observe. Here you can see there is the movement. X is moving far from this sensor. So this wheel is rotated. What is the use of this A axis? So observe these shapes. By only varying the X and Y, we can't make this operation. These curves are possible. You can see over here also. These curves are possible due to A axis because A axis rotates the blade like this. Now in this video again we will see the movement of A axis which will be clearly visible to you. So you can see this motor is rotated with the angle. Again you can see. So this is the movement of A axis. We will understand the C axis operation. Here you can see the cutting wheel is completely vertical or perpendicular to this plane. But here you can see the cutting wheel is slanted. So this is the operation of the C axis. You can see the complete motor is slanted and it is moving forward. So this is the movement of C axis. Here it is coming in X direction and also C axis is operated. It is going upward. So Z axis is operated and it is going upward. Now it is moving backward. So Y axis, this wheel was, this cutting wheel now become vertical. So that was the C axis and it gone left. So this was the X axis. Let me repeat this from here. Observe carefully. So in this video you will see operation of all axes. Let me play from here. So right now X axis and C axis are operated to this position. So now Z axis will be operated and it will move upwards, that you can see from here. Now there is a question. Here there is no any sensor to determine that it has completed its shapes. So how it is operating? So every servo motor has encoder within itself. So the motor and encoders are on the same assembly. So through the encoders, drives get the feedback that it has traveled the required distance. So what in the PLC logic we will write, store the pulses coming from encoder. By the pulses coming from encoder, we will count the pulses by high speed counter. Then we will do comparison of the counter value. If the required distance is achieved, that means if the required count pulses are achieved, based on that, we will give reverse and forward commands to our servo drives. So this is how the programming works. Now we will see it is going backward, so y axis, the wheel become vertical, so c axis vertical this, and it is moving left direction, so this is the x axis. Here you can observe this is the application of c axis. This cut you can see, this is not possible with the ordinary xyz axis. So this slanted cutting is possible through c axis only, and this process is called chamfering process. Now we will see what are the main components through which this machine is built. So let us see that. This is the complete architecture of our project. Here you can see that we have used IoT enabled HMI screen which is connected to our PLC through RS422 communication and PLC and vision machine. So this machine also has, as I said earlier, it has the visual sensor also, which can detect the current position of the cutting wheel. This is the sensor and this is the module for this sensor, and it is connected to PLC through this RS485 communication. So based on this, these pulse outputs are given to servo drives. So you can see there are the 5 servo drives for 5 axis servo motors, and so our input is stone material, and that finished products we get required shapes. So this is the complete architecture of our project. So here you can see again, this is the HMI screen which has lot of parameters, and this is the actual panel MPS for PLCs. Outputs are operated through this relays and other outputs like this servo motor. So let us discuss wiring about this servo motors. Here you can see L1, L2, L3. This is the main supply for this servo drive. Now here you can see UVW. So this supply is for motor, and this upper one is for the encoder that is coming from, that is connected to motor itself, and this is the communication cable coming from PLC. So same configuration is for all machines or all servo drives. So this is how the actual panel looks like. Here you can see there are the 5 servo drives. 3 servo drives are bigger because of main XYZ axis, and 2 servo drives are smaller because A axis and C axis doesn't have much load. This is the complete panel. Here you can see it has wide application and lot of shapes can be formed through this machine. These are the shapes along with their names. Besides this, it also has other advantages like this is very flexible. You can make any shape. This is very stable. It has very high accuracy and precision, and it also has more functions compared to ordinary machines like slicing, specially shape cutting, profiling, drilling, milling, grinding, and etc. This is how the PLC operator screen looks like, and the vision control, especially vision control screen, looks like this. here you can see there are the dimension, and based on this dimension the cutting wheel will be operated. This is the screen. You can see there are the shapes. Based on the shape you select, the respective screen will open. Like you can see, this is the screen for profiling that you can see from here. If I click on this button, this screen will open. The question is, why this machine is called smart machine? So the answer is, the whole project you can see from here, this HMI is connected to internet, and through the internet we can access it through website or through mobile application. It has cloud SCADA, that means we can operate it from remotely, and it can support other desktop tools. So this is how this machine is made smart machine. So what are the advantages of making this machine smart? So it can be operated from remote location. We can debug, that means we can diagnostic or download from remote location also. A maintenance engineer can work from remote location also if there is any update or revision in the programming, so that saves the traveling expense and cost also. Can provide machine maintenance scheme. So how it is done? Machine itself can generate the alarms for preventive maintenance, or if there is internal fault in any sensor is faulty or like that. So that we can also see the real time status of the machine, that how many products have been processed, what is the current shape being processed through application HMI or from remote computer also. Last but not the least, the equipment can give alarm function via email or other methods. So even if the operator is not available there, maintenance team can know about if alarm is coming, so they can go for troubleshooting and servicing it. So after watching such videos, you will definitely give new ideas for making your projects. If you want to get more real life examples like this, show your interest by liking and subscribing our YouTube channel. Meet you with another example in next video.